Okay, so I'm back. Hopefully everybody watched the lectures. So we went over the final or the midterm exam, sorry, on Monday. Overall, the grades were pretty good. Um, uh, I don't remember exactly what the class average was, but somewhere in the 75% range or so. I thought they were uh, the grades overall were pretty good. Um, Ben, yeah, my trip was good. I got some sun. I have some tan lines. So you get to check those out on Monday. Um, uh, so I leave 85-degree weather yesterday and fly into basically Noah's flood and 40-degree weather. Um, but it is good to be back, I think, ready to get back into the swing of things. All right. So anyways, I did email I think two people from class regarding, kind of the exam and stuff. So make sure you're checking your email regularly. But both of those people have already gotten back to me. So if you're not one of those people, you don't have to worry about it. But like I said, I always try to be honest with you about whether or not I think computer science is for you and stuff. So, if you didn't do as well on the exam as you wanted to, I just would just, want you to ask yourself, what are some of the reasons for that? Are you just not caught on yet? Are you still playing catch up? Remember, I have the policy where if you do better on the final exam than you did on the midterm, I'll replace the score you got on the midterm with whatever you get on the final, so you can fix a bad grade. Just make sure you're honest with yourself around the reasons why you may have struggled on the midterm. There were plenty of solid grades. I think we had several 100s, um, several people in the upper 90s, missed a point here or point there, that kind of stuff. I think a lot of grades in the mid 80s, so a lot of solid Bs that basically show very good competency with just some weaknesses here and there, and sometimes it came in the form of like one bad question. You left a question blank, or you struck out on the question completely. Whatever it is. So try not to be too hard on yourself if that was your situation where you really did well on all of the exam that you were able to answer and just came up short on one, just forgot something, or misunderstood the question, whatever it is. Okay, so then the on Wednesday, we kind of caught back up on the uh, our dungeon crawler, and we're now connecting our front end and our back end together. So the homework for today was to update the program to allow a player to leave one room they're currently in, update their current room behind the scenes, such that when the scene loads for the new room, it shows the appropriate exits for that room. All right, so let's go and look at that and see where we left off. I guess before I go any further, are there any questions about anything related to the exam, or I guess anything else at this moment, since I wasn't around to answer live questions on Monday or Wednesday. And I'll hang out for a few minutes after class today in case there's anything you want to specifically talk about. Going once, going twice. Okay, so let's come in here. So right now, if we hit play on our game, we see that our guy is starting off in that first room, and just reminding ourselves that we currently have a dungeon that looks like this. So we are in this first room here where we should have an exit only to the north, not to the west, east, or south. And that is the situation we currently have, where we have an exit to the north, nothing to the east, west, or south. If I try to go south, it won't move. Try to go west, it won't move. Try to go east, it won't move. But I can go to the north. And he is visually leaving the room now, but he's not actually changing rooms. So we've stayed right in the room that we left in. So we're just back into room one again, over and over and over again. All right, so we want to create the situation where when he leaves this room, he is removed from his current room, put into a new room, and then our scene shows this new room as the place he's currently at. So let's look at how we can accomplish that. So I'm going to go ahead and open up. Well, I'll just click on player here. That should get us into our Visual Studio. All right. So remember all the things we put the word controller after, those are our mono behavior scripts associated with Unity, where these files like player, room, these are not mono behaviors, these are our back end. So a player knows their name, they also know about the current room they're in. So when we're running our game in this current state, this guy right here, our visual representation of our player is Chomp. Behind the scenes of him, there's an instance of player. He knows the current room he's in is room one, which has an exit to the north, nothing to the west, the east, or the south. All right. So when we have him head north here and he leaves this room, we want to remove him from R1 and get him into R2 so our second scene can witness that. All right. So let's go to the player controller code. Right. Actually, do we move it to dungeon controller, I think? Nope, that just turns the doors on and off. Who handles those collisions? Here we go. On trigger enter. Yeah, right here. So on trigger enter, when we hit something that's a door, we're printing out that we're loading a scene and we're just loading our dungeon room again. What we really need to do here is we need to remove the player from the current room and place him into the destination room prior to loading the new scene. All right. So we need to go and look at how do we remove a player from a room? We have to remind ourselves of this relationship between players and rooms, whereas a player knows about the current room they're in, but a room also knows about the current player that's in the room. All right. So when we have a player leave the room, that room's player needs to get updated to no longer have a player in it. All right. So just to keep this not having to like hard code null values and stuff, what we're going to do is we're going to have a function, public void, we're going to say remove player. And this guy's job will be to remove the current player from this room. And what does it mean for a room not to have a player in it? It means that this room's current player variable gets set back to null. That is, it's no longer the player that was added to this room originally. So the first thing we'll do is we'll say this dot current player is equal to null. So now from the room's perspective, there's no longer a current player in this room. All right. Now, we also need to let that player know about the room that they're going towards. Okay. So before we lose track of our current player from this room, we need to give it the direction. So why don't we say this? String direction. We need to know about the direction this player was heading when he left this room. We need to get the exit associated with that direction. So why don't we go ahead and have another function here? We'll call this guy, it'll be private. We're just going to internally use it. He's going to return an exit. We're going to say get exit given direction. All right. And what we're going to do here is we are going to go through our collection of exits, finding the exit that is equal to the direction, so we can kind of steal this code right here from has exit. So this guy is going to start I off at 0, keep going as long as we hit the number of exits this room actually has, as opposed to 4 being the maximum number of exits a room can have. Each time through, we'll ask, is the current exit we're looking at equal to the direction you're looking for? If it is, we're no longer returning true, which was what we did when we questioned whether there is an exit in a direction. Instead, we want to return the actual exit. And in the end, if for whatever reason we did not find the exit we were looking for, we're going to return null. We'll say never found the exit. And this guy returns the exit in the given direction. So now we have a private function called getExit given direction that will return for us the exit, the instance of exit associated with that door. All right. So when we remove a player from a room, when that player is heading in a certain direction, we're going to go ahead and say exit E is equal to, well, let's see, let's call it the exit, is equal to this dot get exit given direction, and we'll pass it that direction. And we made this a private function, which means it's only accessible inside of the room class here. We can always change that later on if we find a use for having access to that outside of this class, but we want to keep things as private as possible. So basically from outside of the room class, the way we can get at this function is by way of removing the player. We'll tell a room to remove their current player because that player is heading in a certain direction. Actually, here, no, it's fine. It's fine. So then we'll ask our local function to give us the instance of exit in that direction. And what does an exit then give us? We go and look at exit, and exit knows the room it leads to. And we want to have the ability to get that destination room. Right now, that's private. We already have a getter for getting the direction. We're going to go ahead and give ourselves a getter for the destination room. All right, so now we have read-only access to the destination room associated with an exit. All right, so we just added an ability to our exit class. Now within room, once I have the exit, we can then say room, call this guy destination room, is equal to the exit dot get destination room. So once we have the exit heading in a certain direction as we're leaving the current room the player's in, we can then use that exit to get the room that it leads to, store that in this variable. And then what do? We say destination room dot add player. And the player we're adding to the room, oops, sorry. Is this dot current player. So removing a player from a room when the player is heading in a certain direction requires us to get the exit that we're going to hit, get the destination room that exit leads to, add the current player from this room to that destination room, and then set the local current player to null because the player has now left this room. Now remember, when we add a player to a room, adding a player to the room lets this room know about the player, but also updates that player's current room to this new room. Okay, so it is the room that lets the player know that they've now entered this new room. So we don't actually need to directly let the player know about the destination room here because it's it's happening here. So this updates the player to their new current room. Okay. Now, what do we need in order to remove a player from the room? We need the room that the player is currently in. So if we go back to player controller, what room is the player currently in? Look at our singleton. Our singleton has access to the current player, called the player. And a player has access to their current room. So what we'll say is my singleton dot the player dot get current room. So that's the current room the player is in. And now we're going to say we want to remove the player from that room. And we need to tell it the direction we're heading. Oh, sorry. Get current room dot remove player. Now I need to tell it the direction we were heading. That's what we're going to fill in there. All right. So in order to remove the player from the current room, we need to tell them what room we're heading. Well, how do we know what room we're heading? All we know in here is that we just bumped into a door. And where do we see doors? That means that this physical game object has bumped into our visible trigger up here that represents one of our doors. Now, visually looking at this, we know that can only happen, when it's a door in that direction. But we need to find out who knows about the direction this player is heading when we pressed one of those arrows. So when did we press an arrow? So if we hit the up key, we're updating our singleton to the current direction we're moving. All right. So it is our singleton who knows about the current direction. So from that very first room, if I'm in here and I hit the up arrow, I'm letting my singleton know that the player is heading north. All right, that happens right here. So right here, I can say my singleton dot current direction. That's the direction the player is currently heading. And that will be what our remove player we just wrote will take into consideration by getting the instance of exit in that direction, by getting the room that exit leads towards, and then telling that room to add our current player to it, which ultimately will will update that player in the room that they are now in, and then we'll update this room. Finally, remove the player that just left from this room. That's what we just accomplished there. All right, so if we hit a door, we'll get the current player's current room, remove the player in a certain direction, and then we'll load our new scene. Keeping in mind that when our new scene starts, we get the player's current room, which has been now updated. And we use that information to update the exits and stuff in the new room. Go back here, restart my game. All right. Guessing I didn't save something. Give me a moment. Going to go into player controller here. Actually, I'm going to go into room. And I'm going to say, well, actually, I think I showed you how to use the debugger last time. So we're going to actually use that here. So I'll go ahead and put a breakpoint here in my code. We want to see this stuff occurring. And I can go ahead and tell this guy to attach to Unity or attach to Unity and play. Go ahead and hit play here. I'm going to hit up. I'll attach it to my actual instance of running Unity. Now I'll hit up. Oh, it had updated. I was getting ready to debug it, and but I didn't test it again after I saved my files. So again, whoever I had put in charge of making sure I save all my files needs to, although we'll still go through this exercise. I want you to see this. All right, so we're running here. I'll hit up. Not actually. So I'm going to say attach the Unity and play. We'll go ahead and hit play from here. That should start my game running. Enable debugging for this session. Right. Oh, we still have some old breakpoints. So I'm going to get rid of these guys. So I'll remove this breakpoint. I'll remove this breakpoint. This is stuff from last class. I'll go ahead and hit play here to just continue on until we hit another breakpoint. Okay. So now we hit our chat here. Oh, it was Ben who was in charge of reminding me to save. That makes sense. That checks out. Okay, so now we are in our remove player the very first time. All right, so we're at this very first line of it. So we know before I execute this line, well, we don't even have to do that. Here's this room's current player. The current player is in a current room, and that current room's name is R1. All right, so we're just digging into these variables down here related to the current state of our game. So right now we are inside of a file called room. This is that instance of room, which has a current player who has a current room whose name is R1, which makes sense. That's the room our player started it. All right, so let's go ahead and step over this first line. So now we have our exit. So that's the exit leading in that direction. So here's that exit. So this is an exit heading in the direction north, which is what we expected. All right, so we're definitely getting the right direction. Now we want to get the destination room. So I'll go ahead and step over that line. And we have our destination room here, which should be R2. Yep. So that's the room we want to get to is R2. And we're going to add that player to that room. So what I'm going to do, just so we can see that, I'm going to go ahead and step into, I'm using this guy here instead of step over. I don't want to step over this line and let anything that happens inside of add player occur. I want to go and see what's happening inside of add player. So I'm really, driving home a way of using the debugger, because you're going to start finding it more and more helpful to do this rather than put print statements all over the place. All right, so we'll go ahead and step into add player. So we're right here. We'll step over that curly brace. So when we're adding a player to a room, right now this is an instance of room and we are in room R2. So the instance of the room we're currently sitting in is R2, and we are letting that room's current player get set to the player. All right. So now the reality is, and I'm gonna go and do something here real quick before I step over this line. Notice I just let room R2 know about that the player is now in R2, but we have not let the player know that they are in R2 yet. So if I don't execute this next line yet, but I instead go to, oh, can I get to the current player? I want to show you I don't have a way of getting to it from this guy. This is stuff we didn't write. That's our scene. Well, I'll just tell you what we would find. From our current scope here inside of this instance of room, I don't have access to my player object yet. Although current player should now be set. I've skipped that line, right? Why is this guy null? Let me step out of this for a second. Here's our exit heading to the north with the destination room of R2. Okay. I might have I might have accidentally disconnected from the debugger, and that was the problem. We'll get our destination room. I'll step over. Then we're going to add the player to this room. I'll step in. Then I'll step over that. Why isn't this guy getting the player? This guy is a variable. Let me just run this guy again. All right, so we're in the original room. I'll go up. We'll hit our breakpoint. We get our exit. We go to our destination room. I'm going to step into this guy. There we go. Now our player has a value. So notice here that our player currently has a current room of R1. So from the player's perspective, they are currently in R1. We'll step over this line. Step over this line. So now this room's current player is this player. Yeah, so and this room is currently called R2. Okay, that's this room's name is R2. And the current player that's in the room is Mike. But notice that from the player's perspective, their current room is still R1. So even though the room thinks the player's in it, the player still thinks they're in R1. That doesn't get updated until here on line 22. So I'll step over that. So now notice that our player thinks that their current room is R2. So that's the point when the two line up. When the room thinks the player's in it and the player thinks they're in that room. All right, so there was a moment there, one line of code, where technically the room thought the player was already in there, but the player had not updated themselves to be into that new room. All right, so I'll go ahead and stop my debugger there. We'll go back. We'll hit play. So now when I head north, we see that we are in that room where there's an exit now to the south, which heads back into that first room. And there's an exit there. We also have an exit to the north that heads up the cross dungeon. So now we're at the T. So right now in our dungeon, we just went north, then we went north again. So now we're in this room right here where there should be an exit in all directions. We have an exit in all directions. If we head to the west, we now have an exit just back to the east. So right now, that player should be in R4. Head back to the east. Head to the north. Now the player's in R6. Head to the south. Head to the east. Now that player's in R5. Head to the west. Head to the south. Head to the south again. We're back in our starting room. Okay, so that is our solution for the homework that's due today, or a solution. But what's most important right now is now we have we finally finished making our sandwich. That is our backend code, our collection of instances of player and room and exits. They all now keep track of what we see on the front end. So right now, visually, I'm seeing room R1. Behind the scenes, the player also thinks they're in the instance of room associated with R1. Now, visually, I'm seeing R2. Behind the scenes, the player thinks that their current room is R2, and R2 knows about the player. Visually, I'm seeing R3, R4, so on and so forth. All right, so we're able to traverse through our dungeon now. Okay, now, what would be the next thing that might make sense for our game? Would anybody have a suggestion on the next cool feature? You know, let's say we're not jumping to, you know, crazy video game stuff, because remember, this is going to turn into your next homework assignment. But what might be the next cool thing that could happen in our dungeon? Kind of open it up to the audience for any suggestions on what we might have. Any ideas? Do we want, to start putting monsters in there? Do the monsters move around on their own? We have the ability to fight the monsters? Because right now our player can just run all over the world and the world keeps track of the things behind the scenes. What would you like to see happen next? So this is where we can start using our imagination as software developers and decide, what do we want to see happen next?
Maybe some objects we can pick up.
Objects to pick up. Okay, so what does it mean to pick up an object? So give me an example. What do you want to like pick up a weapon or something?
Uh, yeah, like a weapon or maybe like n nothing random, not like a random object right now, but maybe like a coin or something,
Okay.
or like
Oh,
a weapon or yeah, like something
yeah, I
like
got
that.
you. I got you. So kind of the idea would be if we think about this like a video game, your goal is to collect coins, right? And you want to get as many coins on the level as possible. Now, right now we have no we don't have monsters or anything keeping us from getting to these coins. So at this point, we can just put coins all over the place and collect them and keep track of them, right? But eventually, what we might want to do then is after we've collected once we have the ability to collect our coins, we might want to put obstacles in there between us and the coins, where we don't get to the coin until we, beat the evil troll or whatever it is. I guess we're using chomps, so we probably have ghosts or something, unless we want to have something else. But this kind of that idea is that along the lines of what you were thinking.
Yeah, something like that, or like yeah, like kind of like yeah, like Super Mario-esque type, where like you
Right,
gotta
right.
complete the
Yeah.
level and then you get a pickup.
Yeah, yeah, and you have you have a number of coins that you've earned, that's your points or whatever, but there's those turtles and stuff like that there that are trying to kill you, and when they hit you, you have fewer coins. I know some games also have a thing where instead of like your player dying, you like lose coins. Like the coins give you health, if you will. So that could actually be something we do. We could decide that the player's current health is related to the coins they've picked up. Um, and so when they get into a fight, they maybe have increased their armor, if you will, even though we don't have armor associated with our player yet. But maybe if they've picked up three coins and maybe think about hit points. Let's say they start off with 10 hit points and they've picked up three coins, they kind of have 13 hit points now. They have three extra pieces of armor that they've strengthen themselves with for future battles or something like that, so that when we create a fight scene, which we're going to be doing soon, that kind of gives our player an advantage if they're able to collect some coins or some defense stuff, maybe the shields instead of coins or something, before they get into fights. And then we'll have to decide how they get into fights. So let's see what we got here in our assets folder for pickup stuff. Here's our chomp guy. What do we got as prefabs? We have characters, we have environment, props. What do we got for props? Ooh, power pellet. Oh, cherries. Oh, we can have both. Power pellets maybe give us extra power or something. So for right now, I'll just throw a power pellet in the middle of our room here. Look at that from the side. Let me just elevate this up a little bit. Okay, so every room now starts off with a power pellet. Maybe what we actually do is we place the pellet in the direction we want the player to go, like kind of as a way of getting them to go through the dungeon in a certain order. Okay, so if I just hit play now, even though this power pellet doesn't have any real role, unless it has a collider, in which case it's going to be a problem here pretty soon. Nope, he doesn't. All right, so now every room has a power pellet in it. And we might decide that we want to have power pellets throughout, but we want to have our player capture these power pellets and maybe keep track somewhere of their score. All right. So what does it mean to capture a power pellet? Well, right now our power pellet is untagged. And why don't we add a tag for this guy? So we'll add a brand new tag and we'll call this guy a power dash pellet. Did we spell it right? Yep. All right, we'll hit save there. And I got to click on our power pellet again and make sure we actually tag him with that. This allows us to recognize whether that guy is a thing or not. All right. Now notice that our power pellets, because they were built for that Pac-Man game that we brought these assets in from, notice these guys have sphere colliders on them and they're already set up as triggers. And remember, triggers are the mechanism for keeping a for us to handle this without physics. Because if I take that trigger off and I go ahead and hit play, now our player kind of has to bump over that thing. Our player was a lot stronger, so he made it through it pretty easily, but whatever. So this guy will be a trigger. Now we need to go in and look at our code to see where can we handle a player hitting a power pellet. So we'll go into our code here. We'll go into our player controller. Our player controller is where we have our on trigger enter. So what are the types of things that a player can bump into? Where they can bump into a door. They do that, we do one thing. They can bump into the middle of the room. We do a different thing. Okay. Otherwise, we have them just bumping into randomness, and that's what we just put this thing in there. But now what we've done is we've added a new thing they can possibly bump into. And this is a power dash pellet. All right. And for right now, we're just going to go ahead and do a, well, here, we don't need to do anything here. What we can do just to test our debugger, we want to make sure we can get into this line of code. So I'm going to go ahead and put a breakpoint at this opening curly brace inside of our power pellet and make sure that we are getting into this if statement. So I'll go ahead and save this file. Then I'll hit play up here. That's going to start our game. Shouldn't it have started our game? We had to choose the running version of Unity there. Now we'll start our game. Okay, game's running now. So I'm going to start heading north, and we're going to bump into this power pellet. And now it hit our breakpoint. And we see we are now inside of this code where we created, we hit our power pellet. All right. So somewhere we want to keep track of the points associated with that. Now, we're definitely going to want our power pellet to, so we're going to say other. I'll go ahead and stop our game here. We'll say other dot game object dot set active to false. We'll just do that for right now. So make pellet disappear. So we'll remove that guy from the scene. Go ahead and hit play again here, make sure that that happens. And it does. So now he can pick up pellets visually. He can visually pick up pellets. All right. So what we want to have now for our homework, the update. Right, so now the online code is up to date with this. So our homework, given this code, update your program to allow a player to collect power pellets and keep track of the number of pellets they have collected and show on the game screen that total number of pellets. The total pellets should appear on each scene. So if we collect one pellet in room R1, when we get to R2, we should see the 1 somewhere on the game screen. So basically, we want our guy to be able to go around and pick up pellets throughout our scene. Why don't we say place pellets on the way to all available exits. All right, so what does that mean? That means if we're running our game here, right now there should just be a pellet to the north like there is. When I get to the second scene though, we should have a pellet to the north as well as to the south, so I can pick another one up. Okay? Now, eventually though, what we're gonna do is we want to ensure that once a pellet has been picked up in a room, it no longer should show up in that room. Hint, keep track of the pellets on the back end of your code. So a room should know about the current pellets that should exist in the room. So initially, when I first start this game and I'm in R1 here, R1 should know that it has a single pellet on the way to the north. When I pick up that pellet going there, and then I go back to R1, that pellet should not have been there again. R1 should remember that it now no longer has those pellets. Okay? So we don't want to have a situation where we can sit here and farm pellets moving north and south until our guy is basically invincible. All right, so you want a pellet to only be collectible one time. Make some sense? Questions, comments, concerns, bribes?
I have a question unrelated to the
Okay.
assignment.
Okay. Well, so anybody else have a question about the assignment before I'll stop the recording and then, talk to anybody who wants to stay after class? Nothing? Okay. So I'll do that and I'm going to stop the recording.